So, welcome everyone to the software architecture and design session. My name is Daria. I will be the session chair, and I welcome here 6 presenters that will be presenting the papers. So, we will start with 5 minutes presentations from each of the presenters, and please, using the question feature in your chat, you can right away, even during the presentation, write your questions that you have in your mind, and then after all the presentations, the presenters will answer those questions. Let's start. So we have the first paper, What Do You Want From Me? Adapting Systems to the Uncertainty of Human Preferences, presented by Carlos. Yeah, I give you the floor.
Hello everyone. First let me share my screen and see if this works. Can you guys see my slides?
Yes.
Yes.
Oh, brilliant. All right. Thank you for attending this talk. My name is Carlos Gaviria. I'm a postdoctoral researcher at the Open University. And this is our near paper. What do you want from me? Adapting systems to the uncertainty of human preferences. So autonomous systems sometimes for accomplishing their goals require cooperation from the humans in their environment. And this is especially true in emergency scenarios, where they use robots extensively for search and rescue operations. What you're seeing on the slide is a robot called Hector, developed by the Technical University of Darmstadt. And Hector has some autonomy. It can navigate a disaster zone, it can detect survivors, but it's a bit small. So if Hector detects a survivor that's able to move, Hector can certainly guide the survivor to safety. However, if the survivor detected by Hector cannot move, he needs help. Ideally, this help should come from professional, trained first responders. But in emergencies, first responders are scarce, and they're busy, so in many situations, they might not be available to help a robot. But lucky for us, there are more people in an emergency that can help. What you're seeing on the slide is a picture from the flooding that happened in Peru in 2017. And we're seeing that when tragedy happens, people help each other. And social psychology has an explanation for this. They state that during an emergency, people that were strangers and shared nothing are suddenly united by the experience of a tragedy. They develop a shared identity, and this identity promotes cooperation among the people sharing the identity. And what we propose in our paper is autonomous systems that capitalize in this emergent solidarity so they can achieve their goals. So during operation, one of these rescue robots will face people that share an identity, so they will be willing to help each other with evacuation, and some people that won't. They won't develop the identity, so they will prioritize their own safety. And to make things complicated, detecting identity is hard for a robot and also for us humans, arguably. So the robot will need to make decisions using partial information. And to enable decision-making under this uncertainty, we propose in our paper to use game theory. Both robots that build game theoretic models of the interaction between robots and the humans in their environment. And we choose game theory because of this modeling framework within game theory called Bayesian games that use extensively to model uncertainty in other scenarios like auction, for example. What you are seeing on the slide is our proposed architecture based on the MAPE-K framework. So as a preliminary evaluation, we compare our adaptive robot with two competitors. One competitor was what we call the prosocial-oriented robot that always asks for survivor help. And the other one is a pro-self-oriented robot that never asks for survivor help. We tried 4 scenarios. In our 4 scenarios, our adaptive robot performs better in average expected number of evacuations. Well, that's all I have to say. To recap, for humans and systems to cooperate, we need systems to understand people's preferences and adapt to them. This is especially relevant in emergencies, where there's the potential of benefiting from the cooperation that emerges among survivors. And in our paper, we propose and we believe that game theory with social identity are tools that will help us accomplish this. Thank you very much for your time, and that's it.
Thank you very much, Carlos. That's very interesting. Thank you. And if anyone has questions for Carlos, please write them in the chat, and he will be able to answer after all the sessions. Perfect. Now I welcome Myung-Joo here with the paper from the track of synthesis and performance toward among device AI from on-device AI with stream pipelines.
Okay. Hello, I'm Myung-Joo. I'm a tech VP in Samsung Electronics, and I'm going to show you one of the on-device AI software framework, which is to provide among-device AI pipeline framework for AI applications. This is recent changes in NNStreamer, which is an open source software, and it is hosted by Linux Foundation. And this project is not only used by different Samsung devices, it is also used by different companies already. And let's talk about why in the hell we need to learn AI systems on device, not in server systems in a few applications. In our case, we usually release consumer electronic devices, and such devices usually use the data of user's private data or the data that should be protected. And we usually cannot send such data to servers. So we need to do the AI inferences inside the device, not in servers. And often we use video streams, and they may have too much latency if you send such data to the servers. And lastly, the cost is also a problem. In Samsung, we usually have more than 1 billion devices active daily, and we don't want to send data to the servers from such billions of devices. So we need to reduce the cost by doing the AI services inside the devices. In the previous paper in Exit 21, we have introduced on-device AI pipeline framework. And in this paper, we are extending this framework to among-device AI, which means that we are going to have multiple devices collaborating for a single service or a single application. This framework is already deployed for different wearable, TV, mobile, or even a robotic vacuum or oven devices in Samsung. And we have other users, including NXP, Finders, Cleon, and other companies. So this is the first example of among device AI, which is applied to automotive factories in US. And in this case, a worker has a camera, mobile device, and wearable device. And with these devices, with camera and mobile device, the device will identify what is the task the worker is going to do soon. And after the task is identified, the mobile device will order the wearable device to track and monitor the data. And then it will send back the data to the mobile device so that the mobile device will decide if the listened task was done correctly. And if the listened task is not done correctly, it will notify the user that he needs to or she needs to do the listen task again. And such process can be described in pipelines, and we can implement such pipelines easily with NNStreamer. And these pipelines require two different devices, and we have in among device AI application with these pipelines. It was implemented within 20 lines, and we had no noticeable overheads, and it dramatically reduced the cost of implementation and modifications. And we want to extend such uses to different consumer electronics, not only to Samsung devices, but also to different third-party devices. And we want to keep the consistency of service quality and the context for all such devices at home. Let me go to the last slide for what we want to do with this project. As this is not a proprietary software, but this is an open source software, which is already, we have transferred all the rights to the Linux Foundation, and we are accepting contribution from general public. And you can join us at GitHub, and we accept any contributions from different parties. And these companies, including NXP, Collabora, Finders, and Cleon, they are already contributing to our project, and they are using it for their own services and products. So as an open source software, we urge you to join us, and you can use ours freely for your own products or services. Okay, thank you.
Thank you very much. It was a very interesting presentation. Yeah, please ask questions in the chat. We have the next presenter, Mohammed, with a paper, Decision Models for Selecting Patterns and Strategies in Microservices Systems and Their Evaluation by Practitioners. Please, Mohammed, you have the floor. You're still muted, I guess. Yeah, just need to unmute on the screen. Could you? Nope, we cannot hear you yet. I guess there is some issue with the mic.
Hello.
Yeah, now we can hear you. Okay. Perfect. Yeah, thank you.
Okay, so my paper is regarding decision model for selecting patterns and strategies in microservices system and their evaluation by practitioners. So first of all, I will introduce about microservices architecture. The microservices and architecture is about multiple small, manageable, and independently deployable services. Microservices style brings unique challenges for software organization, and many quality attributes may be positively or negatively influenced. According to research studies, most of the design, development, monitoring, and testing challenges are raised when application is decomposed into microservices. To this end, we propose the decision model that covered 4 microservices design areas.
I'm sorry, Mohammed. We might not see the. Do you switch between the slides?
Yeah, I can switch, but I don't know.
Yeah, if you could maybe switch on this screen, that would be great. Like on the PowerPoint screen, because we cannot see the presentation. Yeah, now we can see the slides like this. But
now I cannot see it.
Oh. Okay.
So like this is fine?
Okay. Yeah, like this is fine. Yeah, thanks.
Oh, okay, that's fine. To this end, we propose the decision model that covers 4 MS design area: application decomposition into microservices, microservices security, microservices communication, and service discovery. So the key aim for this study is to present the decision model that assists practitioners in create patterns and strategies for decision-making microservices system. So basically, decision model map element of the problem space to the element of the solution space. This problem space represent functional and non-functional. Solution space represent design elements. We represent the problem space as a set of quality attributes, and the solution space as a set of microservices pattern and strategies. Basically, we decompose, we propose application decision model for application decomposition, microservices communication, and microservices security decision, and the service discovery decision model. So basically, we use mixed method study. First of all, we identify MSM strategies from literature, and as well as the peer-reviewed literature. And after that, we create the decision model by using a BPMN modeling notation. And finally, we evaluate decision model by conducting an in-depth interview with the 24 microservices practitioners. We use modeling notations, different gates and inclusive, exclusive, and parallel gateways to represent the decisions and pattern strategies, as well as the quality attributes. So first decision model was about application decomposition decision model, which was about how to decompose applications. So basically, we set the two conditions. If the team size is defined, then practitioner may use the several patterns like decomposed by subdomain, service per team, decomposed by business capability, and decomposed by transactions, as well as scenario-based analysis. And similarly, if the team size is not defined, then we can use the graph-based approach and as well as the data flow-driven approach. Our next model was about a microservices security decision model, where we collect, identify, organize, and present the pattern for application level security, communication level security, and code level security. Similarly, our third decision model was regarding microservices communication decision model. So again, we've set the three conditions for patterns, communication patterns, like client's interaction with microservices and interaction between microservices and communication between microservices developed in different programming languages. So you may see the highlighted pattern that we identified. So the impact of the pattern on different quality attributes. Our last model was regarding service discovery decision model, in which basically first we proposed like a need to register services interaction and as well as need to discover the services. And after that, we evaluated our decision model by using different by using interviews where we conducted the interview from 24 practitioners from 12 different countries with from 24 different companies. So most of them for the application developers and architect systems that have the experience with in IT industry on average 3 to 5 years, and with Microsoft with 2 to 3 years. Mostly are from the e-commerce, healthcare, and telecommunications, have the telecommunication background. And we asked some questions regarding familiarity with patterns and strategy for each model. Similarly, for a discussion, understandability with the decision model, as well as for the completeness of decision model. So the most of practitioners were familiar, and they were easy to understand our model, as well as the they were satisfied with the completeness of the decision models. As in a future work, we are planning to extend the proposed decision model, establishing decision model repository, exploring the possible combination of pattern and strategies, and validating the model through an industrial case study, as well as developing a recommendation system that support automation and human decision and selecting the most appropriate pattern and the strategies, while analyzing their impact on quality attributes. So this study was basically present the decision model that leverage pattern strategies and quality attributes for rationalizing design knowledge to assess architect and developer in engineering microservices system. That's it. I can take the questions after presentations. Thank you so much.
Yeah, thank you very much, Mohammed. Yeah, it was very interesting. And yeah, please write the questions in the chat. Perfect. So now I invite John to present building maintainable software using abstraction layering.
Okay, thank you. Let me share. Okay. So hello, everyone. My name is John Spray. Our paper is about a new reference architecture called Abstraction Layered Architecture, or just ALA. So what is Abstraction Layered Architecture? ALA is an architectural pattern. It organizes code at all larger scales of an application or system. It's applicable to any software, monolithic or distributed, for which you want the quality attribute of maintainability. or the related attributes of understandability or constant complexity regardless of system size. Fundamentally, ALA consists of three constraints. 1. The only unit of code is an abstraction. 2. Only one type of relationship is allowed, a dependency on an abstraction that is significantly more abstract than the one using it. And 3. All abstractions must be small. The three constraints give rise to important emergent properties. The abstractions form discrete layers, which we name by the types of abstractions that tend to live in each layer, such as domain abstractions. The architecture is a polyglot programming paradigm, which means it uses many programming paradigms at the same time, such as data flow, event-driven, or UI construction, and others that you can invent. The internals of all abstractions are zero-coupled from one another. In conventional modular or distributed code that used a decomposition methodology, there is typically design coupling, or what I call collaboration coupling, between the modules or classes. ALA converts collaboration coupling into cohesion. A user story is completely represented by cohesive code contained inside its own abstraction in a higher layer. Another ALA property is composability, expressing user stories by simply composing domain abstractions. We trained some intern students on ALA and got them to rewrite a conventional legacy application. We wanted to apply popular metrics to the two versions to compare the maintainability. These are the resulting dependency graphs for the two versions. The legacy one is on the left, looking like a big ball of mud. ALA distinguishes between good and bad dependencies. All of the dependencies in the right graph are good dependencies. We actually want more of them because that means we are reusing our abstractions. Most of the dependencies in the left graph are bad dependencies and illegal in ALA. Unfortunately, commonly used metrics for dependencies, such as CBO, coupling between objects, are unable to distinguish between good and bad dependencies. If they did, they would be useful. In the comparison between the legacy and the ALA versions, the modularity, analyzability, testability, and reusability were all higher for the ALA version. The modifiability of the ALA version was lower in the beginning, while new domain abstractions are frequently needed for building new user stories. But the modifiability improves over time as the domain abstractions mature. The total effort to build the two versions was approximately 12 man-years for the legacy version and 3 man-years for the ALA version. The usual experience of developers is for modifiability to decrease over time, but for ALA it increases over time. It is said that 90% of commercial software is under maintenance. The metrics indicate that significant cost savings are possible. Thanks for listening.
Thank you very much, John. It's a very interesting presentation. And please, ask questions. There is already one question I see in the chat. Perfect, thank you. So now I pass the floor to Satrio with, oh, sorry, that was the timer for 5 minutes. So John, perfectly on time. So Satrio with guiding peer feedback in learning software design using UML.
Okay, thank you, Daria, for the floor. I'm sharing my screen. I hope it's visible now. Yeah, I guess so. Okay, hello everyone. My name is Satrio Adhirukmono. This is the work I did with Professor Michelle Shodrong. We are both affiliated with both the Institut Teknologi Bandung in Indonesia and Eindhoven University of Technology in the Netherlands. So, guiding peer feedback in learning software design using UML. So the background of this study is feedback in learning software design. We know that learning software design is challenging because there are often no solution, and design cannot be tested in the same way that source code does, and there are often multiple perspectives to consider, the different stakeholders of the system in question, and so on. And feedback is useful for students so that they can learn from their mistakes. They're students, so of course they will make mistakes, and students and feedback can help them to learn. But for such kind of open-ended task, a handful number of teachers, it might be difficult to actually give very comprehensive feedback to the students. So another way that they can gain feedback is from their student peers. And there are a couple of pros and cons here. Giving feedbacks to their own peers force students to think deeper on design, and that includes their own design. But in the cons, novice feedback can sometimes be or maybe most of the time can be considered harmful. So from that, we formulated these 3 research questions. The first one is, what type of feedback do students find helpful? And then the second one, how to instruct or guide students to give good feedback or to avoid this harm in novice feedback. And the third one is, how do students use the feedback they receive to improve their design? For our study, the participants are third-year students of informatics program in a software project course where there is this 155 students split into groups of 5, and they work on medium-sized real-world projects, either web or mobile apps with actual clients from different domains, and they need to perform the development using agile methods. After the third sprint or third iteration, peers are asked to give feedback on the design by completing review forms. And upon receiving feedback, each group responds by completing a response form. The review or feedback form contains questions on the following categories: the visual appearance of design diagrams like class diagrams, sequence diagrams, and so on, class and method naming, design quality, and document clarity, overall document clarity. And the response form contains questions on how they would improve their design based on the review and on the clarity of feedback itself. We gathered all this data and performed thorough analysis on this. And here are our conclusions. For the first research questions, what type of feedback do students find helpful? They find it helpful to have positive feedback with specific examples and separate feedback on the syntax and semantics of their design. So this aligns with many findings in the field of education, in which there are, in fact, some studies that try to determine the ratio between positive and negative feedback that can have a better impact to the student. And then for the second research question, how to instruct or guide students to give good feedback, we need to give a precise and directed instruction for points of attention that needs to have this feedback. And we need to ask students to explain the rationale behind their feedback. So this forces a deeper thinking on the design and the quality of this feedback. For the third research questions, how do students use the feedback they receive to improve their design? We found that most of the time it's mostly as we expect, as can be expected, that that students with negative feedback will try to improve in their aspects, and positive students with positive feedback will have fewer plans of improvements. However, we also find that some students with mostly positive feedback still plan to do improvements, while some students with mostly negative feedbacks did not plan any improvement. And this, I guess, shows the motivation and their willingness to be involved in the actual task of design. So here we conclude that good students improve and poor performing students do not improve much. So that is the end of my presentation. Thank you very much for your attention, and I look forward to the discussion.
Yeah, thank you very much, Satrio. We apparently work on a very, very similar topic in our scientific life. Okay, great, thank you. And we have the last presentation by Qinghua Lu on software engineering for responsible AI, an empirical study and operationalized patterns. Please, I give you the floor.
Thank you, Daria. Can you see my screen?
Yes.
Yeah, thanks. Hello, everyone. I'm Qinghua from CSIRO, Australia. So I will be presenting our empirical study on software engineering for responsible AI. First, motivations. We know there are many serious concerns about AI systems' ability, whether they can behave or make decisions in a responsible way. And many organizations and government, they have released AI ethics principles. But the problem with these principles is they are very high level and they do not provide concrete guidance on how to build responsible AI systems. So in our paper, we identified two research questions. The first one is what are the current states and potential challenges developers are facing in dealing with responsible AI issues. The second one is how can ethics principles be operationalized into concrete practice and developers can use through the life cycle of AI systems. So to answer the research question one, we interviewed 21 participants from a research institute with different background and expertise. And we, to answer the second question, we identify a set of process patterns and also design patterns based on the interview results and also literature review. So the table on this slide shows the incidence of themes relevant to principles. So we can see the top three principles are privacy and security, reliability and safety, and transparency and explainability. The least discussed principle is human-centered values. So in the paper, we summarize the major findings. The first group is for overall development process. And the first finding is on risk assessment. So most of the current approach is one of type of assessment, but for continual learning AI system, there's a need for continuous and extensible risk assessment for different contexts, like different culture or different application domains. The second finding is about trust and trustworthiness. So there are two different concepts, but often mixed in practice. So in our interview, some participants mentioned we can consider to use process and product mechanisms to improve trustworthiness, but we also need to offer evidence to our users to improve their trust in AI systems. And one way to improve trust is to attach ethical credentials to AI components, because for the current AI products, usually the vendors just create products by assembling different components from third parties. So by attaching ethical credential, we can show the AI component is compliant to ethical standards. And the fourth finding is about integration of AI model and the non-AI component. So the current solution is mostly about algorithm level solutions, but we do require system level solutions to address the ethical issues which can happen at any step of the development lifecycle. And the second group is about requirement engineering design. The first one is ethical requirements usually stated just as high-level objectives in the project proposal. It's not specified in a verifiable or measurable way as expected system outputs or outcome. The major architectural design decisions in AI system design is whether to adopt AI or not. So AI component can be designed in a more flexible way. For example, we can activate AI component or switch off AI component during runtime, or we can change the decision mode to suggestion mode to make the decisions. The next one is about trade-offs between different principles, like between privacy and accountability, or between privacy and reliability. So the current practice is just follow one principle but override the other one. So we could consider to use design patterns to deal with these trade-offs, just like trade-offs between different software qualities. And explainability and interpretability are also mentioned in the interview as quality attributes. So when we explain the prediction or decisions made by AI system, some participants suggest we should consider background and preference to improve the human trust and use their familiar terms to explain the prediction. The last group is on operation. There's a strong desire for continuous monitoring and validation for ethical requirements. And the current focus is mainly on the output of AI system, like the algorithm accuracy. Some participants mentioned we should also focus on outcome of AI system, like whether the AI system can provide the intended benefits or whether their behavior is proper in some given situation. And the last one is about co-versioning of data model code and configuration to ensure data provenance and traceability. So for the collected patterns, we create a new pattern template based on the traditional one. So it includes type of approach, so whether this pattern is process pattern or design pattern, type of objective, whether this pattern is to improve trustworthiness or it can also improve human trust, and who are the target users of this pattern, and who are the impacted stakeholders of this pattern, and what life cycle stages are covered by this pattern, and whether which principle is this pattern relevant to, and what mechanisms are covered by this pattern, or whether this pattern is easily to be applied or difficult or medium level. What kind of consequence can be caused by this pattern, and what are the known uses, what are the existing applications for this pattern. That's all, thank you.
Yeah, thank you very much. Yeah, please ask questions also in the chat. And we had a number of questions already answered by the authors, and we maybe will start with Carlos. So I think Carlos has answered all the questions that were asked in the chat already. And does anyone want to ask a question to Carlos about his paper by voice? No? Okay. Yeah, I see a number of questions. Yeah. I see a number of questions still in the chat. So let's take a look. I think there was a number of questions also to John. Have you answered all the questions in the chat, John?
Haven't. I've been listening to the presentation.
Yeah,
sorry.
to the presentations. Okay, so let's take a look. So because I think that Myung-Ju also answered already the question that was asked to him. So the first question was, do you envision a way of automatically detecting illegal dependencies? Could it be potentially incorporated into IDE plugins?
Okay, yeah, good question. And yes, definitely. So what we do in ALA is the layers, we put them in folders in your solution. And so any dependencies that are just in a folder are obviously illegal. You can only have dependencies from one folder down to the next folder. So that's really quite an easy thing to do in your IDE. Okay, so
yeah.
Does that answer that question?
Yeah, Carlos, I think it was you who asked the question.
Yeah, it definitely does. Thanks.
Perfect. Thank you very much, John. Yeah, there is another question. Do you happen to have an example at hand of an old and corresponding new abstraction?
We only have the really quite big application that I was talking about that we did the metrics on as a direct comparison. So that is something that I am still working on, is code written in a conventional way, and then the same functionality written in the ALA way for direct comparison. So apart from that, I have quite a few examples in different domains in the online book written in the ALA version. One of them is Robert Martin. He did a coffee maker kind of learning example size project in one of his books. And so the existing code for that is available on the internet, and the ALA version is in the online book for ALA.
If you could share a link in the chat later on, that would be great for the online book, so people would know what were.
Sure.
Yep,
Sure.
yeah,
Sure.
Yeah, thank you very much.
Yes. Okay, so does that answer that question? I don't have a lot, but there's a little bit.
Yeah, thank you. Thank you very much. I think that that will be already a very good start to understand it. And yeah, there was the last question, I think, for you. Using machine learning to identify abstractions in conventional code, how do you plan to prepare the data set?
Oh, okay, so this is a difficult one. It's definitely in our long-term plans to automatically identify the abstractions in conventional code. In fact, this is absolutely essential if we're to succeed, because so much software work is done on existing code. If we can't give a clear path to refactoring it, then we can't use ALA basically, except on new projects. So as far as actually identifying the abstractions using machine learning, I'm not an expert on machine learning, so I have collaborators at the local university who have ideas for that. But I think, we'd be taking source code and first moving it to an abstract syntax tree, which is easier to get the semantic meaning. It's going to involve semantic meaning. The whole reason we're using abstractions in ALA is because that's what our brains use. Our brains don't use encapsulations, compilers do, but abstractions is what we use. So yeah, getting those out of source code is, I think it's going to be quite difficult. You have to understand the semantics of the program to the same level that our brains do. So yeah, but we are working on it.
Yeah, I think Myung-Ju is happy with the answer. So yeah, okay, thank you very much. So yeah, I guess all the rest of the questions were already answered in the chat. So please, the audience, you are welcome to ask your questions. You can just unmute your mic and ask the questions to any of the presenters. We still have time.
I haven't actually answered
you haven't
questions.
Yeah, sure, please.
I've answered your questions about the evolution of models. So next I will start with Myung-Ju's question. So you're talking about architecting courses for developers with like 10 years of experience. So I guess it would have a very different kind of feedback. I mean, they have this many experience, so the value of their feedback would be much higher than those of the students. Unfortunately, I am not looking into this kind of setting for now, so I cannot provide many advice, I guess, for this. But I suppose the frameworks for model evaluation is a good start to is a good place to start to look into questions that you can ask these developers to evaluate their peers models. Does that answer somewhat? Okay. Thank you. Then the next question is from Carlo. Is it common that a student unlearns design knowledge due to bad student feedback? Well, this is a very good question, and we haven't taken a look at this angle yet, but this is a very good direction of a further study regarding this feedback from peers. So thank you for this input, but unfortunately I cannot give you an answer now.
Yeah, thank you, Satrio. I have an extra question for you, if you don't mind.
Sure.
So for the peer feedback, do they have some feedback guidelines that they are provided with when? So you provide the student with, let's say, a checklist, or how does it work?
So we provide some kind of forms or questionnaires, I guess. And in most of the aspects that we evaluate, we ask for both quantitative score on this particular aspect and qualitative or open-ended answers that they can elaborate on why they give this particular score. Yeah.
Okay, and does the peer feedback count for the final mark, or it is purely formative?
No, at this point we are not considering it for the final grade because it's still in an experimental stage. But maybe in the next year, if we have more conclusions that shows the validity of this method, maybe we can try to incorporate it.
Okay. Yeah, that's a tricky one. I mean, that's something that you still have to check after those students, so it's a double work probably.
Yeah, exactly.
Okay. So, any more questions? Yeah, John, thank you for sharing the link. So if there is no more questions, we can probably conclude. So I thank everyone for attending, and of course all the presenters for very, very interesting talks. And yeah, looking forward to see you at other conferences and at this conference as well. And yeah, we'll stay in touch, I guess. So thanks a lot, and see you soon.
Thank you, Daria.
Bye-bye.
Thank you.
Thank you.